Hello, friend. How are you? I hope you will be fine. So, today we will start our topic. My topic is today we will discuss as that why carbon atom. That why carbon. Today my topic is why carbon atom. Why carbon atoms cannot make four covalent bonds between between two carbon atoms. Why two carbons cannot make four covalent bonds between each carbon like this? Why it cannot make? Why always the maximum bond between two carbon is three covalent bond, and the remaining one is will opposite to their, it means that it will be to 180 degree to each other. Why it cannot make four covalent bond? Here it is very simple. There is very simple logic, not it is very complicated question. It is very simple question because here if you see the structure of carbon has six electronic configuration, that is called 1s2, 2s2, 2p2. You can also write this, that is 1s, that is 2s, that is 2p, 1s, 2s, 2px, 2py, 2pz. Here is one two electron, here is two electron, here is two electron, but it will but 2pxp orbital is degenerate orbital. So according to Hund rule, first electron will be unpaired, first electron will be unpaired, remaining unpaired. So if at that is the ground state of electron carbon, and there is the ground state electronic configuration of carbon. If we excite this electron to here to into pz, so the configuration become, that is 1s, that is 2s, here is 2px, 2py, 2pz. Here is 2 electron, but in valence shell, in L shell, here is one electron, one electron, one electron, one electron. So the so the valency of carbon become 4. It means that 4 carbon can share 4 electrons. So why it is the valency of one carbon, it is also the another carbon have also same valency like this. 1s will contain one electron, 2s contain one electron, 2p will be contain 3 electrons. So the in L shell, in valence shell, in last shell of carbon, here will be 3 unpaired electrons, so they can, so the carbon it can share these all electrons. So why two carbon cannot share 4 electrons to each other? The maximum sharing electron between two carbon are 3, means 3 carbon can I mean 3 electron can be shared by one carbon to the another carbon. There is no case there cannot possible to the carbon share 4 electron to another carbon. So it is why. So if you see you can see that here is a in valence shell, here is one electron in 2s, and and 3 electron in one electron in 2px, 2py, and 2pz. Here is one electron, here is one electron, here is one electron, one electron in each case. So you can see that here this is the electron, this is the orbital, 2px is the orbital that is lying on a x plane, that is the x plane, x plane, x plane of coordinate. Here y, it is the y, it is y. means that is the y plane. Y plane containing 2p y orbital. Here it will be oriented on y plane, and the 2p x orbital will be oriented on x plane, while 2p z will oriented on 2p z on a z axis, z plane. It will oriented on z plane. So here, but the 2s electron, s electron has spherical shape, so it will spherical around the nucleus, the central atom. So if carbon have the s electron, it is the one orbital, it is another orbital. So this is the x orbital. Now this is the y orbital, this is x orbital, and this is z orbital, this is 2s orbital. So same case of another carbon. Here is a same case. Here is one electron, one orbital, one orbital, one orbital, one orbital. That is y axis, that is x axis, this is z axis, and this is the 2s orbital. So here one is along x axis, one is y axis, one is z axis. Here you are watching that x-axis orbital are shared to each other, or x orbitals of each carbon share with each other by head-to-head overlap, and make a sigma bond. It makes sigma bond. So here is the py orbital, 2py. Here is it is 2py orbital. Oh, so it will overlap sidewise, it will overlap sidewise, so it make pi bond, it make pi bond. And the other one is that is 2pz. Here this is 2pz, there is 2pz. It will also overlap sidewise, it will also make pi bond. So if it will make pi bond, so here three bonds are bonded, here three bonds between two carbon are bond are formed. But the s orbital, the 2s orbital, it cannot approaches to the carbon of each other, because the size of 2p orbital is greater than the s orbital. S is very near to the carbon atom. So s cannot approach to each orbital, to another orbital of s of the carbon. So s cannot approach to each other. So s will combine with the here to the hydrogen atom. That is the bond, that is the bond of hydrogen. So it will make a sp hydrogen, sp hybridization. It will make sp hybridization, sorry, not sp hybridization, means it will be sp overlapping the s electron of carbon and the p, not sp, at the s is overlapping, s overlapping, because one is the s carbon, one is the s orbital of carbon, and the another is the s orbital of hydrogen. So it will make a bonded. So carbon cannot make four covalent bond. It can always make two covalent, it can always make maximum three covalent bond, not cannot make four covalent bond. So I think it will be clear, there will be no confusion remain. So I think we should be stop here, because nothing is remaining. What can I teach the remaining thing, because here is nothing remaining. So thank you very much, goodbye, best of luck. Be read, be reading books, different books, be organic books. So okay, thank you, okay, bye, good luck.